All right, today we're going to tackle a huge topic, securing your own little corner of the cloud on Amazon Web Services. And we're going to make it simple by using this really powerful analogy, thinking of your cloud environment as a university campus that you have to protect, from the front gate all the way down to the most sensitive files in the library. Let's dive in.
So you've gone out and carved out your private section of the cloud, what AWS calls a virtual private cloud, or VPC. Just imagine it's the plot of land for your new digital campus. The thing is, right out of the box, it's completely open. So the real question we're answering today is this: how do you build the fences, the gates, and the guard posts to control exactly who gets in and where they're allowed to go?
Okay, before we even think about building walls, we have to know what we're building on. And in the cloud, that starts with a fundamental rule. You have to understand who's responsible for what. This is a core idea known as the shared responsibility model.
So think of this model as a really clear division of labor. AWS handles what they call security of the cloud. That's the physical foundation. They're securing the data centers, the actual servers, the cables running under the floor. They're securing the very ground your campus is built on. Your job? That's security in the cloud. You are responsible for everything you build on that land, your apps, your data, and who gets to access it. If you build the library, it's on you to lock the doors at night.
So let's start building our defenses from the outside in. The very first line of defense for your campus isn't the lock on some specific office door. It's the main gate that controls access to the entire property. And this is where we meet our first security tool. That main gate, in our analogy, is your Network Access Control List, or Network ACL for short. It's a type of firewall that operates at a really broad level. It protects entire districts within your campus, which in cloud speak are called subnets. So you can think of the Network ACL as the border patrol for a whole section of campus, deciding what traffic is even allowed to enter the area in the first place. A Network ACL is your broad, blunt instrument. It can explicitly allow traffic in, but just as importantly, it can explicitly deny it, like putting a known troublemaker on a Do Not Enter list. Now, the most critical feature to get your head around is that it's stateless. This means it has zero memory. If you write a rule to let a delivery truck in, the gate doesn't remember that truck. You have to write a completely separate rule to allow that same truck to leave again.
The way it makes decisions is super simple and very strict. The ACL looks at its rules in numerical order, from lowest to highest, and the moment it finds a match, it stops. So, if a request comes from a trusted admin, it matches Rule 100, and boom, it gets in. If not, it moves to the next rule. This strict, ordered logic makes it a fantastic tool for blocking huge categories of unwanted traffic right at the campus border. Now, just because some traffic made it onto campus grounds doesn't mean it's a free-for-all. Our next layer of security is much more detailed, much more granular. We're moving from the main gate to the front door of each individual building. This is where we add a whole other layer to our defense.
And that is the job of a security group. A security group is another kind of firewall, but instead of protecting a whole area, it wraps around a specific resource, like one single server or one database. It's like having a dedicated security guard standing right at the front door of your library or your science lab.
Now, security groups have a few key differences from our campus gate. They're way more specific, working at the instance level, that building door. They also only use allow rules. By default, everything is just denied. But the most important difference, the real game changer, is that they are stateful. This guard has a memory. If you allow someone to enter the library, the guard remembers them and automatically lets them leave. You don't need a separate exit rule. This makes them way more flexible to work with.
Okay, let's just put these two side by side to make it crystal clear. The Network ACL is the campus gate. It's broad, works at the subnet level, uses both allow and deny rules, and it's stateless. It doesn't remember anything. The security group is the building guard. It's granular, works at the instance level, uses only allow rules, and it's stateful. It remembers who's coming and going. You really need both for a complete security setup.
All right, so we've controlled the flow of traffic to our buildings. But what about the people inside the campus? Just because someone is allowed into the library doesn't mean they should have access to the rare books collection. This isn't about network packets anymore. This is about permissions.
This is where Identity and Access Management, or IAM, comes in. Think of IAM as the campus ID and keycard system. It's not a firewall. It doesn't care about network traffic at all. Its entire job is to answer two simple questions. First, who are you? That's authentication. And second, okay, now that you're here, what are you allowed to do? That's authorization.
IAM enforces these rules using things called policies, and you don't need to be a coder to get what these are. At its heart, a policy is just a set of permissions written in plain English. For example, an analyst's keycard might let them enter the building and view reports, but that same card is going to get rejected if they try to use the document shredder. They are granted only the absolute minimum access they need to do their job. This is the principle of least privilege, and it's totally central to good security.
So we have our gate, we have our guard, and we have our keycard system. But how do these three very different tools actually work together?
Well, it's because a single lock on a single door is a single point of failure. A really robust security strategy layers these different controls so that if one of them is misconfigured or fails, another one is there to catch the threat. So let's follow a single totally valid request to see how this works in practice.
Okay, let's trace the complete journey. A legitimate request from an administrator arrives. First, it has to get past the main campus gate. That's the network ACL. Check. Then, it needs approval from the guard standing at the specific building's door. That's the security group. Check. Finally, once inside, the user swipes their key card to perform an action, and the IAM policy is checked. Only when all three of those layers give a green light is the request successful. That's it. 3 complementary layers of defense: the network perimeter, the instance firewall, and finally, user identity.
And this really brings us to the core philosophy of modern security. It's not about building some impenetrable fortress that's impossible for your own team to even use. It's about surgical precision. It's about designing a system that grants the absolute minimum access required for every person and every application to do its job, and not a single permission more.
So let's lock in the key takeaways from all this. Number 1, security is a shared job between you and AWS. 2, network ACLs are your stateless campus gates. 3, security groups are your stateful, smart building guards. And 4, IAM is the keymaster, deciding who gets to do what once they're inside.
And that leaves us with one final but really crucial question to think about. Building these security layers is just the first step. The real ongoing challenge is tuning them. Are your rules actually helping our team get their work done, or are they just getting in the way? Finding that perfect balance between airtight security and productive freedom, that is the true art of mastering the cloud.